So the last part of the question on the back of the page. The capacitor in the circuit has a capacitance of 22 microfarads. The resistance has a resistance of 47 kiloohms. Making use of your completed table above and your answer to part 3, or otherwise, estimate the time after the switch is closed for the PD across the capacitor to have fallen to 5% of its initial value. So we're going to use our equation, and our equation is V is equal to V naught e to the minus t over c times r. We can calculate the value for c times r by multiplying our two numbers in the question. That's 47 by 10 to the 3, or 47 kiloohms, multiplied by 22 microfarads. And when you multiply those two out, you get an answer of 1.034, and that's seconds. So if we're going to use that in our equation in a minute. Now, we're told that the PD has fallen to 5% of its initial value, and its initial value was V naught. So the 5% has to go back into a decimal again. So the new V is now equal to 0.05 V naught. So we're going to replace this in the equation. So 0.05 V naught is equal to V naught e to the minus t over, and then our time constant is 1.034 seconds. The V naughts cancel each other out. To get rid of the e, you have to take log of both sides, and it's the natural log, so it's ln of 0.05, and that's equal to minus t over 1.034. And if you apply all that out, you'll end up with a minus answer over here, but whenever you multiply log of 0.05 by 1.034, t comes out to be 3.097 seconds, or 3.1 seconds is your answer. That's the end of the podcast for Homework 2.